my name is Marco, and I'm here to present the roadmap update about Ignition and ROS2. Next slide, please. So I'm software engineer for Open Robotics, and we like to create software and hardware platforms for robotics, and we like to use those platforms to solve important problems and help others to do the same. Next slide, please. So Open Robotics is it's spread out of around the world, mostly North America, Europe, and some part of Asia. Most of the team is in California. That's where the headquarters are, and the second biggest office is here in Singapore. Next slide. So first, I'm going to talk about Ignition. And Ignition has its origins on Gazebo Classic. And Gazebo was a monolithic architecture, and Ignition is trying to rewrite this into a collection of loosely coupled libraries. So the main idea is that these libraries will have minimal dependencies between them, and they can be used for different purposes, like not only simulation, like Gazebo Classic, but also like mathematical transforms, or even like video encoding or process mining. Next slide. So these are the releases that have been in Ignition up to now, being the latest Dome, which was released in September this year. And we'll talk about most of the features that are already in Dome and some of the ones that will come in the next one, next release in Edifice March 2020. Next slide, please. So the main focus of Gazebo Ignition is close the gap. This means an effort to reduce the disparity between Gazebo and Ignition, with the focus to facilitate migrations. And for that, there's also a feature comparison page that you can check to see what are the differences between the two projects right now. Next slide. Next slide. Yeah, so these are the focus areas that I'm going to talk about, and let's see what are the features that we have there. Next. Regarding the UI, there's tools for model and work creation, editing, and saving. So you can save words to SDFs, and you can upload them to Fuel, which is our online repo for these models. And you can use tools to insert online and local models. Next, please. You can also insert shapes, basic shapes. This is an example of just inserting a box, sphere, and a cylinder. Next. Also, we have a key publisher, so you can use this key publisher to publish keys to a topic, and then these keystrokes can be mapped into other messages that can be resulting in action, like, for example, increasing velocity value. Next. So you can also choose the angle you want to view the scene, and this can be basically related to the selected entity or whole frame. Next. Align. You can align models, and you can do that along along the bounding box of another model. You can insert snap values for transaction, for rotation. Next. There's also a plotting visualization tool that has been created. So you can visualize different types of data. You can visualize simulation physics data or transport network data. On the animation here, you can see how easy it is just to drag, I think it's the X value into the plot, and it starts plotting right away. Next. There's also LiDAR visualization, and basically this adds a new type of sensor to the Ignition rendering library. It extends the capability of the laser visual that came from Gazebo, and it has some enhancements, like you can select right sticking on an object, or new visuals like points or ray lines. Next. This is a topic viewer that we saw before, that you can basically list published topics. The user can access the fields and nested fields and make them draggable, so you can drag them. For example, what we saw before in the plotting plugin. Next. So regarding actors, animated models are actors, basically. There's two types of animations that we have. So we have skeleton animations, which basically relative motion between the links in one model. And then we have trajectory animations, which basically carries all the actor links around the world on a trajectory. With this command, you can play around with the follow actor SDS. You can see how it works. And this animation just is given the combination of a skeleton animation and trajectory animation to move the actor around the world. Next. This is just an example of Ignition running 1,000 of actors with 100% real-time factor. Next. We also have a buoyancy model that has been introduced. You can play around with this command again, and you can see in the animation an example where there's three very simple submarines. One floats in place, the other one has no buoyancy and sinks, and the other one is buoyant and goes up. You can change the buoyancy to the different values on the buoyancy plug. Next. We also have particle effects for smoke and gas, and basically you have different attributes that you can be configured, like meter size, rate and duration, color, and other. Next. There's also an optical tactile plugin that has been developed. This sensor, this is to simulate a sensor, a tactile sensor, which uses a depth camera and a contact sensor. It basically measures the surface normals of the objects in contact. So in the animation, you can see how we display the surface normals of the object next to the sensor. Next, for next release in Edifice, we're working on shaders for underwater camera effects and mesh level of detail. Next. The trivial physics engine, it's a physics engine that we are developing at Open Robotics with the main focus on fast simulations without real physics. So we found out this is sometimes the need. So basically, we do basic supports on models, link collisions, velocities, but we do not support anything like dynamic, like forces, mass, with the idea of speeding up the simulation. Next. So we also have the attachable joints, which basically allows two models to start off rigidly attached and then get deattached during simulation by polishing. Next. We also have improved resource path planning. We have spatial build files, and also the SDF website has updated with new documents. Next. We also have a tutorial series with videos for DOME. Improve emission physics documentation, and we're working on designing enhanced distributed simulations and improve the support for Mac. Next. So yeah, currently the LTS version of Ignition is Citadel, so it was supported for 5 years. The current latest one is Dome, that will be supported for 1 year, and the next one will be Edifice, will be also supported. Next. And now I'm gonna talk a bit about ROS2. So let's see what's new on it. Next. This is not ROS2, this is ROS1, but because it's the latest version and the last version that is going to happen, I just wanted to mention that Nightingale Gems is out and it's going to run for 5 years support, and it will be the last one. So you guys have 5 years to do the transition to ROS2 if you want. Next. So current release, the latest is Foxy, and it's the first time that we're starting with a rolling release called rolling release. So this will get all breaking changes, and it will serve as the baseline for new releases. So Galactic, which is the next release, will be basically branch out from rolling. Next. The focus of ROS2 is product readiness, which the idea is to make ROS more suitable for production scenarios, improve the out-of-the-box experience for common use cases, documentation, and solve disparities between ROS1 and ROS2. Next. So these are the focus areas that I'm going to talk about, and let's see what's new. Next. All right, so let's talk about the middleware. For Cyclone DDS, we got full coverage on QoS, security plugin now running. We got ISO zero copy messaging, and we got the object management group DTS C++ API. For fast RTPS, we got sync and async publishing. We got shared memory transport, and we got modern DDS C++ API. There's a very important change in the way DDS interacts with ROS in Foxy. And basically before there was a one-to-one mapping between participants and components. And now, instead of doing that, the one participant, it's created per context. Basically, most of the applications will have one context per process to short. And this is with the idea to not create that many participants, improve the whole performance of ROS. Most of the stuff that is happening at this level should be transparent for everyone. There's also a focus to bring ROS2 and DDS to parity with low-net messages and with the wait set to give the ability to wait on suspicions without an executor. There's also improved real-time support with static containers and with a custom allocator in ROS IDL. Next. Things that we're working on for the middleware are functions to be implemented in the lifecycle node to match the node, event notification, executor refactor to improve performance and determinism, improve discovery performance, new methods for of discovery. And we're having a look at there's people working on Zeno, which is non-DDS subscription software that can also be with ROS. Next. So regarding the tooling, ROS2 has some improvements in storage, packaging, has full QoS management. The Python API is now matching the ROS1 version, and it also has there's some efforts going on to investigate and improve the performance. There's the ROS Doctor, which is a tool that can help us check all different aspects of ROS2, platform versions, and it will warn you about some possible errors. And you can also use it to test the sub multicast send receive quality across the book. Diagnostics tools has also been ported, and you can also cross-compile workspaces for ARM-HF and ARM-64. And now login also allows per logger. Next. In terms of security, there's a node description language, which basically associates the interface that describes how the component communicates. The node's components communicates to other nodes. And this is not only for security, it also helps for other things. Security also had to adapt to the new participant node mapping that Foxy introduces. Improve support for security config and plugins on the Cyclone EBS and Fast RTPS. And the security working group is also working on security without file system for embedded devices. Next. Regarding capabilities, there's a stable functional SLAM implementation now available on ROS. Some drivers have been ported in the sense boxes. Turtlebot 3 has been updated. Some on-robot testing has been done, like in terms of navigation. And we're working on multi-level and multi-map support, the release of the version 1.0 and cost-map filters with the idea to set traffic lines, different speed zones, stuff like that. Next. Also, in terms of manipulation, MoveIt is out of beta, which means that they are feature complete with MoveIt 1. There's the pallet parking demo for autonomous vehicles, and Autoware Auto has reached the milestone 1 foundation. Next. Finally, in terms of DevOps, we have ROS Windows support for GitHub Actions, and we have a Windows virtualized CI for jobs. Some quality levels in the core packages have been reached to version 1. RCL CPP and its dependencies have been certified. An update to ROS2 Arduino Yocto and Open Embedded has been done also. And some sanitizer results in RCL has been addressed with the idea of potential deadlocks, data races, more leaks. So next. So we still are looking into have pull request testing in CI for all tier 1 platforms, test coverage of use cases, micro-OS virtualized CI, CI improvement, like auto scaling or output. Next. So finally, the documentation, we have some consolidated ROS2 documentation. We've improved the infrastructure, auto-generate per package stuff, some intermediate advanced tutorials, ROS1 to ROS2 porting and documentation, and the navigation website has also been improved. Next. Yeah, so the current Foxy release is the 3 years release LTS, with the next one being Galactic, that will be ported for 1.5. Starter will be 3 years and above being an LTS. We still haven't decided how long that one. Next. And that's all on my side. Thank you very much.